Hello, I welcome you all to your own channel MSK Learning. Now in this video, we will discuss about the kinematics of flow, and our topic is the velocity and acceleration in a fluid flow, right? So you all know that velocity is a rate of change of displacement and the acceleration is the rate of change of velocity, right? So now we will see this velocity and acceleration from the in context of fluid flow, right? So basically we are dealing with the kinematics, means we don't consider the forces which causes the motions, right? So what is that velocity and how to find the velocity in a fluid flow, and how to find the acceleration in a fluid flow, and what is the convective acceleration and what is the local acceleration, those things we are going to discuss here. So here, that let v is the resultant velocity at any point in a fluid flow. Let u, v and w are its component in x, y and z direction. So you have a v is the resultant velocity, you can say. It means that we are going to express this into the vector form. As you know, the velocity and acceleration both are the vector quantity. So the velocity component are the function of a space coordinate and time, means the velocity is a function of position as well as time. So first of all, we see that we can categorize the velocity into three components, that is u, v and w, means on x, y and z. So u is equal to function of x, y, z and time. Similarly, v is the function of x, y, z and time, where x, y, z is the position and t is the time, and w is equal to f3 of x, y, z into time. Right now we can express this u, v, w, means the component of the velocity in three direction, that is x, y and z direction, in a vector form. So the vector form of this velocity is resultant velocity v is equal to, we can write ui plus vj plus wk, where I, j, k are the unit vector. So whenever you have to find out the resultant of the given velocity vector, so what you will do, you can square root and the algebraic sum of square of the coefficient of this vector. So what is that? That whenever we have to find out the resultant, means resultant velocity is nothing but the root over of u square plus v square plus w square. Whatever the velocity given in the vector form, that is ui plus vj plus wk, what is the coefficient of I coefficient is u, what is the coefficient of j coefficient is v, and what is the coefficient of k coefficient is w. So we will do that is square root of u square plus v square plus w square. So this is our resultant velocity. Similarly, now we are going to see the acceleration. So acceleration is also vector quantity. It means that it is a function of position as well as time, right? So we can find the acceleration in a three component, that is in x direction, y direction and z direction. So acceleration in x is ax, acceleration is y is ay, and acceleration in z is az. So what we are doing, that we are considering, let ax, ay and az are the total acceleration in x, y and z direction. So now first of all you can find the ax. So as I told you, that acceleration is the rate of change of velocity, means the du by dt. So acceleration in x direction is what? Ax is equal to du by dt, means once you differentiate the velocity in with respect to time, you'll get the acceleration. So if you are differentiating the velocity in x direction, you'll get the acceleration in x direction. So by using the chain rule, we can say the dou u by dou x into dx by dt. This is the dou u by dou x is the partial differentiation. So plus dou u by dou y into dy by dt plus dou u by dou z into dz by dt plus dou u by dou t, means the acceleration is also a function of position as well as time. So further, you know, that is dx by dt means what? Rate of change of displacement is the velocity. So when you are differentiating the x direction with respect to time, you'll get the velocity in x direction, that is u. When you are differentiating the y direction position with respect to time, you'll get the velocity in y direction, which is v. And when you are differentiating the position in z direction with respect to time, you'll get the velocity in z direction, which is nothing but the w. So from these data, this equation ax can be right, that dx by dt is u, dy by dt is v, and dz by dt is w. So the equation will become u into dou u by dou x plus v into dou u by dou y plus w into dou u by dou z plus dou u by dou t. So this is what you have, a acceleration in x direction, that is ax is equal to see, ax is equal to du by dt, that is u dou u by dou x plus v dou u by dou y plus w dou u by dou z plus dou u by dou t. Similarly, you can write down on the ay also, that ay is what? Ay is nothing but you have a dou u dou v by dou t. So when you apply the chain rule, you'll get the ay is equal to dou v by dou t, u into dou v by dou x plus v into dou v by dou y plus w into dou v by dou y plus w dou v by dou t. Similarly, acceleration in z direction, that is means what? Az is equal to dw by dt, means u into dou w by dou x plus v into dou w by dou y plus w into dou w by dou z plus dou w by dou t, right? So this is what we got, the acceleration in x, y and z direction. All right, now so this acceleration is known as the what we call it as a local acceleration, right? And if for a steady flow means what? The fluid properties does not changes with respect to the time, means dou u by dou t, dou v by dou t, dou w by dou t will be 0 for a steady flow. So in case of a steady flow, this term, that is dou u by dou t is equal to 0, dou v by dou t is equal, and dou w by dou t is equal to 0. So once you remove this, means with the unsteady flow, that whatever the acceleration you are getting, that we call it as a convective acceleration, right? So what I'll do, that you just pause the video and write on these things, right? Either in your university exams or any competitive exams, you get this question, that right now. So next what we will do, that we'll solve one problem related to the velocity and acceleration. Okay, yes. So now after doing this, we can say the acceleration vector is what? That a is equal to a, this is the resultant acceleration, you can say a is equal to axi plus ayj plus azk. Again, I, j, k are the unit vector. So resultant, how we find? That is a square root of summation of a square of the coefficient, that is ax square plus ay square plus az square. I coefficient is ax, y coefficient is j coefficient is ay, and k coefficient is az. So you can get the resultant. So now you have one question on the screen, that a fluid flow field is given by v is equal to x square yi plus y square zj minus 2xyz plus yz square k. Prove that it is a case of possible steady incompressible fluid flow. Calculate the velocity and acceleration at the point 2, 1, 3. So these are the position is given, that is coordinate is given, x is equal to 2, y is equal to 1 and z is equal to 3, and the velocity vector equation is given to you, right? That is v is equal to x square yi plus y square zj minus 2xyz plus yz square into k. Right, first of all you have to prove that it is the whatever the velocity profile is given, this is the possible case of fluid flow in a steady and incompressible. Incompressible means what? Density is constant, that is rho is equal to constant, and the steady means the fluid property is not changes with respect to the time. So whenever we have to see the whether the fluid is a that given fluid is a case of possible flow, it means that it must satisfy the continuity equation. So the velocity vector is given in a 3 dimension, that is in x, y and z. So it means that if the continuity equation of a fluid flow is satisfied, the if the fluid is following the continuity equation, that is dou u by dou x plus dou v by dou y plus dou w by dou z is equal to 0, it means it is a case of possible fluid flow for a steady and incompressible, right? So now first of all what we have to do, we have to write on the given data. So you can write on the question. So this is what you have a solution, right? And given that v is equal to x square yi plus y square zj, right, minus 2xyz plus yz square into k. So if you compare that, if I show you that how we have written the velocity vector, that is velocity vector is ui plus vj plus wk. So we have to just find out the coefficient of I, j and k. So I coefficient is what here? That I coefficient is x square y. So here I'll show you that I coefficient is x square y, j coefficient is y square z, that is positive positive, and k coefficient is this one, right? That means minus 2xyz minus yz square. Got it? So we can write that I coefficient is means u, this is v, this is w, right? ui plus vj plus w. If you compare, right, so you can say u is equal to x square y, all right? So and v is equal to, sorry, that v is equal to y square z, and w is equal to minus 2xyz plus yz square, right? So we have to satisfy that, well, means we have to prove whether it is a possible case of fluid flow or not. So first of all, you have to find out the partial differentiation with respect to x, y and z, right? So first I'm finding that dou u by dou x, right? So here that dou u by dou x, let's differentiate this with respect to the x. So this just I'll show you, that is, this is what x square y, you're partially differentiating with respect to x, so it means that this is the 2xy. I hope you know the partial differentiation. And again you can say dou v by dou y is equal to what? Dou by dou y, y is equal to v is equal to y square z, right? So it is 2yz, 2yz, right? Now then finally you have a, what we call it as a sorry, that is dou w by dou z, right, is equal to dou by dou z, and this is what minus 2xyz plus, oh, sorry, this is minus only, I'm very sorry, this is minus, right, make a correction, minus yz square. So this first you have to differentiate with respect to z, so it is minus 2xy, and this is minus 2yz, so it is, we can write minus 2xy minus 2yz, all right? So this we got. Now, so first of all we can say, here I'll go again, so you can write if you don't, right? Now so here I'll go, okay, so just wait. So we can say that is, for possible case of fluid flow, we can write some statement that for a possible case of fluid flow, the continuity equation should be satisfied, right? The continuity equation should satisfy. So what is the continuity equation? The dou u by dou x plus dou v by dou y plus dou w by dou z is equal to 0. If any fluid is following this, satisfying this, it means it is a case of, so dou u by dou x is what? Dou u by dou x just now we calculated, I'll show you again, 2xy, dou u by dou v by dou y 2yz, and this is the minus 2xy minus 2yz. So we can substitute. So this is what dou u by dou x is, the 2xy plus 2yz minus 2xy minus 2yz, right? So 2xy minus 2xy get cancelled, this will get cancelled, is equal to 0. It means that the whatever the velocity profile is given, it is the possible case of fluid flow. So you can say hence v is equal to x square yi plus y square zj minus 2xyz plus yz square into k is a possible case of fluid flow, all right, is a possible case of fluid flow, right? Now, so once it is the possible case of fluid flow, then you have to find out the velocity and acceleration at the given point, right? So first we will find that velocity at 2, 1, 3. It is given, means x is equal to 2, y is equal to 1, and z is equal to 3. All right, so we can say v is equal to what you have, x square yi plus y square zj minus 2xyz plus yz square into k. Okay, so x is what, 2, that is 2 2s are 4, into y is 1, so 4i, this is 1 into 3 plus 3j, right? Okay. Then 2 into 2, 4 into 1 into 3, 12, right? And 1 into 9, 12 plus 9 is 21, so minus 21k. This we got, right? So resultant we have to find. So resultant is what, that you can say resultant velocity that v is equal to root over of square of this coefficient summation 4 square plus 3 square plus minus 21 whole square. So on simplification you get some value, that is, let's say this is 21.587, right? Whatever the unit is given, so here I'm writing the unit, it is not mentioned meter per second or something like that, right? So this is how you have to do. Here you have to just substitute the x, y, z values, right, and you will get this equation. Okay, now then you have to find out the acceleration. So here we are going to find out the acceleration at 213, right? So again you can pause and write, please. So now we are going to find the acceleration at 2, 1 and 3. So we are saying acceleration at 2, 1 and 3, right? So acceleration is what, just now we have written that ax is equal to u into dou u by dou x, u into dou u by dou x plus v into dou u by dou y plus w into dou u by dou z. We are not taking the dou u by dou t. Why? Because it is a steady flow. Steady flow means it's the properties of fluid does not changes with respect to the time, means dou u by dou t is 0, right? So first of all, u is what, x square y, and v is equal to we know that y square z, right? And w is equal to minus 2x minus 2y minus 2x yz minus yz square, right? So first of all, what we will do, that you can find you can say u is equal to x square y, right? So here only you can write that dou u by dou x is equal to what, is equal to 2xy is equal to 2xy. Okay, so this or else directly we can or leave it like, otherwise you will confuse. V is equal to it is what you have a y square z, y square z is means dou v. Okay, right? So not now, that v is equal to y square that v is equal to y square z. Okay, but dou u by dou y, here you have to find again that dou u by dou y is equal to what, this only, that is dou by dou y into x square y. It is nothing but you have a x square only, it is x square. Again you need to find out dou u by dou z. So this is what you have, a dou u by dou z is equal to dou by dou z. X is what, u is x square y, so x square y means we don't have z, so it will be 0. Now if I put u is equal to this, v is equal to this, and z is equal to minus 2xyz minus yz square, and dou u by dou x is this one, dou u by dou y is this one, and dou u by dou z is this one. So we'll get the ax. I'll show you here that ax is equal to what, ax is equal to u into this. Just you try to understand that u into this one, that u is equal to x square y, and dou u by dou x we got the 2xy, right, into 2xy, very carefully, plus v is equal to what, v is equal to y square z, that is y square z into that dou u by dou y, dou u by dou y, dou u by dou y is what, x square. Okay, x square plus w is what, minus 2xyz minus yz square into dou u by dou z. What is the dou u by dou z? Is equal to 0 into 0. So this finally, I hope you got, right? So it's nothing problematic, right? So ax is equal to what? Just multiply the 2x cube y square. So ax is equal to 2x cube y square, and this is what you have, a x square y square z plus x square y square z, and this is 0, so we can write like that only. So now we can substitute x is equal to what, that is point is what, 213, means acceleration we are finding at 213. X is 2, y is 1, z is 3. So we are substituting into this, that is ax is equal to 2 into 2 cube into 1 square plus 2 square into 1 square into 3. So 2, 8, 16, 4 and 9, 36, right? So 36 plus 2, 8 and 16, right? And 4th is a 12. So 12 plus 16 is 28. So ax you got, that is, here you can write ax is equal to 28 unit, right? Let's leave it as it is. Come to the ay. Okay, now so ay is equal to what? Ay is equal to u into dou v by dou x, right, plus v into dou v by dou y plus w into dou v by dou z. We don't have a dou v by dou t. Why? Because it is a steady, right? So u v w is same, that is x square y, and v is y square z, and z is minus 2x y z minus y z square. But we have to find out the dou v by dou x. So here dou v by dou x is equal to what? Dou by dou x into v is equal to what? V is equal to y square z, right? So this is the y square z, means we don't have a x here, so it will be 0. Okay, now then we have a dou v by dou y is equal to what? Dou by dou y, and this is y square z, so it is 2y z. All right, okay. So again we can find dou v by dou z is equal to what? Dou by dou z into this v is what? Y square z only, that means z differentiation is 1, so it is y square. Okay, now so ax is what, ay is equal to this one, that is, again you can write here, that just I'll show you, that is ay is equal to u into this, u is what? U is x square y into dou v by dou x is 0, so it is 0, plus v into dou v by dou y, v is equal to y square z, and dou v by dou y is 2yz plus w, right? So w is what? Minus 2xyz minus, just hold on, so minus 2xyz minus yz square, and this dou v by dou z is nothing but the y square. So again you can simplify, so this term will be 0, this you multiply and this you simplify, so you get this, that is here, just a moment, that ay is equal to 2y cube z square, right? And this is what you have, a y 2xy square z minus yz square, right? So it is something which is like that. So this you got 2y cube, 2y cube z square, this is z square, right? And this will be what you have, a minus 2xy cube into z and minus y cube z square. Okay, so then we have to find out the ay at 2, 1, 3, means x is 1, 2, y is 1 and z is 3. So 2 is not, x is not there, so this is 2 into 1 cube into 3 square minus 2 into 1, 2 into x is 2 into 1 cube into 3 minus 1 cube into 3 square, right? So this is what, 2, 9, 30, 9, 4, 2 is 18, and this is 2 to 4, and the 12, this is 18 minus 12 is 6, and this is 9, right? So it is nothing but the minus 3 unit, right? So you can do the calculation. It's quite simple. Minus 3 units. This is the AY. Okay, now let's circle it. Then finally we have to find out the AZ. So please, if you want, you can hold and you can do the calculation, right? Again, I'm showing you once. Okay, all right. Now then we can find the Z directions. Come back to here, that is acceleration in Z. So you can write that is AZ, that AZ is equal to what? U into dou W by dou X plus V into dou W by dou Y plus W into dou W by dou Z, right? So U is same, that is X square, Y is Y square Z, and W is this. So first of all we have to say dou W by dou X. So means what? Dou by dou X into W is what? Minus 2xyz minus yz squared. So it's X is 1, so it is, you can say, minus 2yz. This will be 0, right? Again dou W by dou Y. So this is what? Dou by dou Y into minus 2xyz minus yz squared. It is Y is same, that is minus 2xz and minus z square. Okay, then meanwhile you can write, right, and dou W by dou Z is equal to what? That is dou by dou Z into minus 2xyz minus yz square. So Z is this, that is minus 2xy and minus 2yz. Okay, so simply you can substitute. So this is what further you can write. Az only here. So U into dou W by dou X. U is what? You have a X square Y into dou W by dou X. You got, that is minus 2, yes, minus 2yz, right? So this is minus 2yz plus V into dou. V is what? Y square Z, y square Z, and dou W by dou Y is equal to minus 2xz minus z square, right? So minus 2xz minus z square. Continuation, I'm not writing here, this is continuation, plus that is W into dou W by dou Z. W is what? That you have a minus 2xyz minus yz squared into dou W by dou Z is minus 2xy minus 2yz, right? So once you substitute xy and z value, or you can simplify, right, or directly you can substitute now only. X is 2, y is 1, y is 1, z 3, y is 1, z 3, like that you'll get. So directly I'm writing. I hope you understood, right? So this is what you have. Az is equal to on simplification you'll get the 123 units, right? Now then you can ax, ay, az you find. Now you have to find out the axle, means you can express this into the vector form. So we can write, therefore the acceleration in vector form is what? That is A is equal to axi plus ayj plus az k, right? So axi is what? X is nothing but we got, that is 28 unit, so 28i, and this is minus 3, so minus 3j plus 123k, right? So resultant acceleration, you can find that resultant acceleration, right? So resultant acceleration is what? That is square root of ax square plus ay square plus az square. Okay, so this is what you can say, square root of 28 square plus minus 3 whole square plus 123 whole square. Okay, so we got this on simplification. We'll get some value that is 126.18 units. Okay, so this is how you will solve the problem. Thank you.